Okay, so when you have a system of a cart on some kind of platform where the cart is attached to another hanging mass, where the mass is hanging over the edge like that, I'll call this the mass of the cart, and this one's like the mass of some kind of hanging object. Now we want to be able to come up with a formula for the force of tension is the idea, and it's something that can be derived through Newton's laws. So the relevant forces that are important are your hanging mass is going to feel a force F, and then there's going to be this tension force which is always smaller than F, which could be like Ft, and then the cart feels that same tension force, and the tension force is really what causes the cart to accelerate forward. And so if you were to unwrap this and just show it in a linear analogous system, the idea is that you're applying a force to one object and not the other, but the first object is towing the other. So we have this, the tension force. Yeah. The tension force doesn't contribute to the net overall motion of the system. So you let the whole thing be the system, and the system can't exert a force on itself. And this force of tension exists completely within the system. Like, it's not caused by anything from the outside. So it's not what we'd call an external force. It's like internal. But this force, this applied force due to gravity, it is external. It's from outside the system. And so it would be the net force in this situation that is responsible for accelerating all the mass. So one equation that you could write would be that F net is equal to the mass of the system times the acceleration of the system. And so what is the mass of the system? Well, you've got your m cart and your hanging mass. And so they would combine. You say F net on system equals m cart plus the mass of the hanger times the total acceleration. Alright, then what do? You also come up with a new choice of system. This is all part of the derivation of it. So now you just focus on, like, let's say the cart. And the cart only has one force on it that matters, and that would be Ft. And so for the cart, the equation for Newton's second law would be Ft equals the mass of just the cart times the acceleration. But they have acceleration in common is the point. So since they have acceleration in common, and it's the same value for both, you want to solve both equations for A. I'll solve this one for A. You get A equals F net divided by the mass of the cart plus the mass of the hanger. And over here you get A equals Ft over the mass of the cart. And so what ends up happening is, since A is equal to this in this equation and A is equal to that in the other equation, then those expressions must be equal to each other. So you combine them through algebra. You can solve for Ft. by cross multiplying. And you end up with this. It's applying Newton's second law to two different choices of system, and just going off of his laws, this is what we'd arrive with as an equation that just always gives us the tension in the string. It's based on a proportion of how much of the mass is concentrated in the cart versus how much of it is in the hanger. As the formula shows, the more that you have in the cart, like, the larger your tension will be.